Okay, so let's get the community call started.
Yes. Can you share the agenda for today?
Yep, so I'll be sharing my screen. I'm Gyosi Gyoza, and I'm speaking with Patty on the stage. We'll be hosting today's community call.
Yes. And I just joined the Topology team. I don't know if you. I don't think I introduced myself so far. So
Please
I
do.
don't. And maybe some of you have already been to a Mu event. We did Mu Chiang Mai, we did Mu Buenos, Mu Accra, and what else? Well, Crecimiento is part of it, and there will likely be a Mu Chiang Mai again. I don't know if you know about those, but those are very cool events that we had for developers across the world. And yes, so I want to bring all the fun and community knowledge to Topology. So I'm very happy to be here. And you'll see some of what we've been working on together very soon.
Absolutely. We're very happy to have Patty joining our team, and we can't wait to build our community up and house more events together. So with that, I think we can start the call today. This is the fourth community call on Topology Protocol, and this is our agenda today. We will talk about Topology newsletter, followed by DEF CON plans, followed by some updates for you regarding the development of the Topology Protocol, and finally we have a Ask Me Anything session. You can ask us anything.
Yay, yes. So first, we want to. We are working on ways to present all the fundamental concepts that we have in topology to the community. So when you join a community, there's usually the glossary to learn. So there's a local glossary for every DAO or every community and every protocol. And right now we are building that glossary with all of the content, all of the fundamental content in topology. And we are spreading the news via the newsletter. So every 2 weeks, we are sending out a piece of information that you have to read, you have to know, and that will help you understand more what topology is all about, as well as help you find your way. So if you ever want to build your own project with us on top of topology, so all of that will be important knowledge for you. And there are also ways for you to get involved. So you're talking about all of the official announcements will be there, and any events that we are gonna attend. So maybe there's an event nearby where you live. You're attending one of the large events like DevCon, and all of that content will be posted via this newsletter. And of course, the protocol development updates, which is the one of the core aspects, one of the core topics of this community call. So if you want to receive this to be part, just scan the QR code, and yes, and then you'll be subscribed. That's this is one of the newest additions we had. The first newsletter is already out with the white paper. I will post links very soon. So if you haven't yet seen the white paper, it's so intense, full of information, and we are breaking down all the topics from the white paper during the next newsletters as well. So I think this is it about the topology newsletter. There was time for you to scan the QR code, but if you still haven't, I will share a link in the chat later. Nice. And the next topic, yeah, so do you want to say something about this? No.
Yeah.
All right. And the next topic is about DevCon. So, who's coming to DevCon? I imagine you all know what DevCon is. There's no one here that is super new to Web3, only people who are new to topology, right? If you want to use the chat, let us know if you are coming to DevCon so we can also consider uh, how many people from the community are coming. And while you're doing that, so use the chat. While you're doing that, so DevCon is going to be huge. And there are many communities gathering before DevCon in Chiang Mai. Chiang Mai is so close to Bangkok, it's like 1 hour flight. It's a very short flight. And and many communities are like building hacker houses, pop-up cities, pop-up villages to gather, to work together to have to prepare for hackathons and prepare for DevCon before DevCon happens. And we want to be there, so you can count on us on a hacker house or hacker village happening before DevCon. We are going to be present during DevCon as well, of course. So the team will be there and we'll have some insight events. But before DevCon, we'll definitely be there. If you are interested, stay posted because we're gonna post more information soon. And last time, I'm sure that Akash remembers. That's how we met. We had a very fun time in Chiang Mai. We used to work during the day because there was a co-working space. You couldn't work at night, all night. But well, and then during the night, we were having dinner together, the whole community, and there's a lot of. It's a very. It's a place for crypto nomads to come. So there is a lot of movement, night movement there, and also the weekends are very cool for you to explore the city. So there's a lot of local food, local culture you can explore. There are amazing parks and hikings you could go. So there are plenty of options. There's a spa day nearby with cold plunge for those who are brave enough, and a swimming pool. So there's a lot of fun things to do together, and it's basically a nice moment and nice place for us to get together, work, build. So we're gonna be building CROs there, and yes, and hang. So we will actually meet each other there. And this is our plan right now. More information, more details soon. And yes, if you are excited for that as well, let us know. We're happy uh, to organize it based on what you love the most as well. So yes, this is it.
Nice. Thank you, Patty.
No, thank you.
Go ahead.
No, we just had someone new joining. I was gonna say hi, but I cannot really.
Right. Yeah, I think so. We brought up the idea that our DEFCON plans will be announced soon, but the high level idea is come build with topology and come make something with CROs, which I think brings us to the next topic which is what is the status quo about CRO development? Where do we stand today? What can we do today, and so on and so forth. Maybe before we go there, since we have new faces in the call today, I'm very curious to know what do we already know about topology protocol, because that will help us think about how to explain things and discuss things with you. So feel free to message in the chat. Where did you learn about topology? What do you think topology protocol does, and what is it about, and so on. And I cannot see the chat, so Patty,
Yes.
I'll have to ask you to interrupt me anytime.
All right. We have dudes typing. And yeah, some people are typing right now, but
Okay.
yeah, it would be great to hear more
Yeah.
from the new people if you know the basics. I saw a message in one of our chats of someone looking for information on topology regarding math, as topology uh, is a math expertise, which is not exactly what we do. But so you can ask anything. Really, it can be any first intuition.
Mm-hmm. Yeah, there's obviously a very big jump from this slide where we talk about coming to build with us and upcoming plans, and this slide, which is a whole bunch of tech jargons in your
Yeah.
face. So yeah.
Yes, we just had a question asking what is DevCon, and then
Ah.
this question from Dutz. And Kono answered that DevCon is one of the biggest Ethereum developer conferences. And yes, every year DevCon happens around the world in one place. So last time it was in Bolivia, every 2 years, sorry. Last time it was in Colombia, right? In Bogota. Am I right? Yes. And now it's happening in Bangkok, in Thailand. So it's the place where all developers gather and build cool stuff. There is a lot of presentations at the conference, but also, and most importantly, maybe the side events are very interesting, like what we're going to do. So, yes. Let's see if somebody else wants to share how much knowledge they have about
Mm-hmm.
topology. Brian's typing. Tianyu, I think you already know about topology, but you can also let us know. Okay, Brian said that he's into gaming physics, environment, and SDK. SDK.
Mm-hmm.
But he's but I
Right.
think there's a question there, so he's not sure exactly. Yeah.
Nice. Yeah, that is definitely relevant to our protocol. Okay,
Okay.
so
And
I think oh, go ahead.
no, I was gonna ask if you can talk about how your background is important or not, also to understand this slide. And Tiana just said that topology is about P2P networks and potentially persistent storage.
I think the
So
first part, 100%. The later part, I can relate to why you said that. Maybe that's not exactly the way we describe the protocol. But I can relate to that description for sure.
nice.
Yeah,
Do you
so
want
I think, yeah, we can move on and give this slide a go.
Mhm.
And I'll try to pace through the slide. And after this slide, we have a AMA session, so any questions is welcome there. Let's do this slide first. So we have done a set of things since the last community call in terms of developing the protocol. What's done is on the left side of the slide. So starting from the top, we have protobuf and wasm. What that means is that we have integrated the usage of protobuf for serialization over the wire, as well as integrating WASM in the sense that we want to have CRO. And for those of you who may not be familiar yet with what CRO is, imagine for any smart contract platform, you make smart contracts. That's the program that you write and put it on the blockchain for people to access. That's smart contract. So moving to topology protocols, CRO is the program you create and you write, which is powered by topology protocol, and anyone can access your CRO without permission, depending on how you set up the permission, but at the same time. And it runs very fast and it works directly over peer-to-peer. There's no server in the middle, and so on. So that's CRO for you. And we want to have CRO executable in WASM. The reason being WASM is a cross-platform runtime. So for Ethereum, you would need smart contracts that execute in the Ethereum virtual machine, and you need specific runtime to be able to execute Ethereum smart contracts. But for CRO, we're aiming for the goal where developers of CROs can write their CRO in any programming language, as long as it compiles down to executables running in WASM. And in topology node, which we are developing, it has WASM as its runtime. So as long as your CRO programmed in whatever language you like, as long as it compiles down to the bytecode that can be executed in this WASM runtime, the topology node can run your CRO. So that's the reason why we want WASM as a cross-platform VM. Most browsers run VM, the WASM. WASM can run on desktop environments as well as embedded environments. So it's very cross-platform already. Okay, moving on from there, we have Hashgraph. And Hashgraph, for those of you who may not already know what it is, it can be a little bit abstract. But what Hashgraph is, let's find a simple way to explain it. So we all roughly understand what blockchain is, right? Blockchain is a chain of blocks, and these blocks record what happens on the blockchain. So these are transactions or events, like who transfer how much money to who the other person, who did what at which block in time. So it's a chain, it's a history of what happened in the past, and they look like a chain. But in the world of CROs, we don't have a chain to record its history. Instead, we use a graph. And the reason is graph, you can imagine, it can grow in multiple heads, right? It grows in multiple dimensions. Chain only grows linearly forward, if you picture in your head. But graph is like a multi-dimensional chain, and it can grow with multiple heads. And so that is one reason why CRO can run very fast, is because it allows the graph to grow at many different heads at the same time. Many players and users sharing the same CRO, they can modify the graph at the same time, growing the same graph, but on their own copy in different directions. And they are also constantly trying to communicate their graphs with each other so that this graph, at the end of the day, looks exactly the same for every players or every users of the same CRO. So imagine a graph that records everything that has ever happened with a CRO, this program, and it grows very fast, and it grows in different ways at different users or players' devices. But because these machines are constantly synchronizing with each other, it is guaranteed that the hash graph or the history of the CRO will look exactly the same at the end of the day. Okay, so if we have the idea of this graph as a representation of the history, we can now talk about the bullet points. So first thing is causality check. Causality check basically means that hash graph allows you to ask the question, I know event A happened in the past, and I know event B also happened in the past. for a given CRO. Tell me if these two events are causally related or they are independent. If they're causally related, it means that either event A happened before or after event B. If they're independent, then they happened at different places. They were done by different people, and when they were done, event A and event B, when they were generated, their generator or their actor had no knowledge of each other's event, so that they were actually done concurrently. They were done independently without the knowledge of each other. That's what we mean by when two events are causally independent. But if they're causally related, that means one is happened before or after the other, meaning that one was done with the knowledge of the other. So there may be cause and effect connection between them. So causality check basically allows you to ask the question, two events, what's the relationship in terms of cause and effect? And this is useful because for a program that people are doing things to it at the same time and doing things very fast, your program may want to know these events and their relationship so that your program knows how to handle that. If you need to order them, or you can just allow them to be fully parallel, right? Like, so for people that understand how cryptocurrency work, we have the spending problem, right? Like if I have $1 and I spend $1 with Alice, I cannot spend the same dollar with Bob. So ordering these two things really matter. I can't spend the dollar twice. But for other things, the ordering doesn't matter. I can do independent things, or multiple people can do independent things, and they don't need to be strictly ordered. The end result still looks the exact same. So causality check is useful in this regard. Okay, moving on to linearization. So linearization is the idea that you have a graph, and each vertex or each node in the graph. So imagine a graph looking like a bunch of circles and connections between the circles. Okay, so in the hash graph, each of these circles is an event that happened in the past, or to be more precise, is an operations that were done on the CRO. Someone did something on the CRO. That's a little circle in your graph. And linearization basically means you take a graph and you transform it into a line of circles. So you squash it into a single timeline. And the reason why linearization is needed is because if you want to compute the state of the CRO, so let's say your CRO starts from empty state, all variables initialized to 0 or whatever initial state you have. And then after a whole bunch of people did things to your CRO, and your CRO's history grow like a huge graph, right? Now you are curious, what is the state of my CRO after this entire history of people doing things to my CRO? In order to compute your new state, you need to squash your graph into a timeline and then apply these operations one by one so that you get the new state. So linearization is useful and necessary in this way. Okay, and there are relations between causality check and linearization. And that brings us to the next topic, which is concurrency semantics applied to pairwise operations. So this is a really huge mouthful. But if you don't look at the screen and you just hear my words, I'll try to be I'll try to make it very simple here. So concurrency semantics basically means that high-level idea is when people are doing things to your CRO at the same time, what does it really mean? What should your CRO behave when people do things concurrently at you? So we can imagine the use case, a very simple use case, when I have a single number. That's my CRO. It is a single number. And I have 10 people trying to change my number at the same time. And while these people are changing my numbers, they have no knowledge of other people changing my numbers. So these 10 people, they're changing my numbers at the same time, and they happen concurrently, right? So this is where we talk about concurrency semantics, which is, what does this mean when people are changing my numbers at the same time? How does my number behave in the face of that? And I can define my own semantics. Okay, so I can say, okay, so if people are changing my numbers at the same time concurrently, then I choose to not order these changes. Okay, instead I can say I will pick the largest numbers of all these numbers, and I will set that largest number as my number. Right. So if 10 people are trying to change my numbers, and each of them trying to change my number to a different number, let's say 0 to 1,000, I'll just pick the largest among them and say that is now my new number, and ignore the rest of them. So that is one kind of semantic, which is I choose the maximum. There are different kinds of semantics, right? I can choose the minimum, I can choose the medium, I can pick a random one, but I need to describe or define what does my CRO or what does my number behave in the face of concurrent operations or concurrent edits to my CRO. That is what we call concurrency semantics. And coming back to the slide, we say semantics applied to pairwise operations. That means that our current code base, or what we have done in the past 2 weeks, allows you to describe semantics that are applied to pairwise operations or 2 operations at a time. So you can say, my concurrency semantics looks like the following. If 2 people are editing my CRO at the same time, I will check their names or their IDs, and I will pick the IDs that are that comes later in the dictionary. So I'll sort these IDs in alphabetical order, and I will pick the one whose ID comes later in the dictionary, and I will pick his operation and ignore the rest. And this is in pairwise operation, right? Because I'm saying I look at 2 operations, I look at their generator's ID, and I pick the one that comes after it in the dictionary, and I choose that. So this is a pairwise semantics. But we do want to support arbitrary semantics that can work across arbitrary numbers of operations. So this is what we shipped already, but we're looking to make it more flexible over time. Okay, so that brings us to what we are working on now, which is a whole bunch of things. The first one on the list is finality. Finality is also known as consensus, and people coming from the blockchain space, we all know what consensus is, right? So consensus is we're trying to reach an agreement on what happened in the past, or what goes into a block, or what is the order of transactions in a block. That's consensus, and another name for consensus is finality. It's some agreement that we agree is final, and we don't change it anymore. If we change it, then we're kind of reorganizing the blockchain, and we don't like that. Right? So we want to be able to agree on information that is final, and we don't change it anymore. That's finality. And in the CRO land, finality is also useful, in the sense that if you remember how CRO works, right? You picture a lot of players' machines, and they are all sharing the same CRO, and they all have their own copies of the same CRO, but they're changing their copies at the same time. So their copies look different temporarily, right? But they're also constantly communicating with each other so that their copies are synchronizing. Now, finality basically means that at a moment in time, can we, like all these players, agree on what actually happened? Like, agree on like a graph that we all agree is going to be final, and we never change anything about that graph. We leave it as final, and we move on from there. That is called finality. Is for replicas of the same CRO to reach agreement on a graph that is finalized, and we're working on that. The reason why it is useful is, for example, if a CRO wants to talk to a blockchain, we know that when you send a transaction on a blockchain, and if it's included, if it goes on chain, it is not very careful about what you submit to the blockchain. So for CROs to talk to a blockchain, it's quite obvious that the information sent from a CRO to a blockchain needs to be finalized information. So that's one way why finality is useful is imagine building an application on CRO where it's running very fast in multiplayer, but you want to send something to the blockchain, maybe to swap NFTs or to change account balances in some financial applications, then that's when you need CRO to reach finality. Okay, the next thing is synchronization. Synchronization, as we mentioned, right, all these different copies of the same CRO, they're constantly communicating and synchronizing with each other. But the way they synchronize can vary. So they are naive way of synchronization, which means I'll tell you what I have, everything I have, and you tell me everything you have, and locally I'll compare and we'll be the same, right? So this is obviously correct, but the issue is if you tell me everything you have, you're going to take up a lot of bandwidth because your graph may be 1,000 nodes and you're sending me your entire graph over the internet to me. And if I do the same and everyone is doing the same to each other over the network, then you have a lot of information that's traveling. The bad part about it is I may already know. So your graph and my graph is not completely completely unique, different, right? I may have some knowledge that we share actually in our graphs. So it will be ideal if you're only telling me the differences of our graph and vice versa. I'm only telling you something that you don't have already on your side. And that helps make the synchronization much more efficient. And it also it's efficient on many different aspects. So we're working on a better way to synchronize these replicas. Okay, the next item is WASM end-to-end developer experience. What that means is that we have shipped WASM in our node implementation in the sense that you can create CROs that can be compiled down to WASM and runs in the node, and it works. Now the issue is CRO needs to be very, very easy to build with. That's the whole point, is we're creating CRO as a new building block or this new Lego on the block that people can build castles with and different multiplayer games and whatnot with it. And CRO needs to be very simple to build with. That's the whole point. And so we really care about developer experience, and we're doing an end-to-end refactor so that you can create CRO in a way that's easier than what we have already, but it still compiles down to WASM and be able to execute in the runtime of the topology node. So that's what we mean by end-to-end developer experience here. Which brings us to the next item, Hashgraph end-to-end. It's a similar idea here. So we have integrated Hashgraph in the sense that our node implementation assumes every CRO has a Hashgraph. Like every CRO, the history of the CRO is represented in the form of a Hashgraph. But we have some end-to-end things to do so that it is sort of reconciled or it is sort of compatible with the rest of the topology protocol stack. And there are a lot of details that we won't mention here. Our entire code base is open source. You can track our progress if you're curious. Okay, so that brings us to the last two items, which is documentation and spec. So we've been creating and working on documentations that describe how everything works in a much more friendly way than you directly reading the code base. And we're also working on a spec. A spec is strictly lagging behind our implementation effort in the sense that we don't write spec in a speculative way. We write spec because something has been implemented and it's working. So we record our knowledge and the design in the form of a spec or specification. And the goal of the specification is that anyone who follows the specification can implement or can come up with their alternative implementations. And as long as every implementation follows the same specification, all these implementations can interoperate with each other. So we are creating a topology node, yes, but it is fully open source. And when we have the spec ready, anyone can follow the spec to create alternative implementations or different designs for topology node. But as long as everyone follows the same spec, all these nodes are able to discover and connect and interact on a P2P network, regardless of who implemented the node. Okay, so that concludes all of the updates. And one thing to note is that WASM integration has been a beast for us because there's a lot of plumbing work between programming languages. Specifically, we require still currently CROs and CRDTs or any program we want to run in our runtime to be expressible in assembly script. But we probably don't want our developers to having to program their CRO in assembly script, because the whole point of WASM is you should be able to create your CRO in whatever programming languages that can compile down to WASM. TypeScript being a programming language that is very, very common among and well known among web developers. So we targeted TypeScript initially. But the issue is bare TypeScript doesn't directly compile down to WASM bytecode. So we're currently using a assembly script as a call it intermediate representation, and the process of doing that is quite hairy. It's not elegant. So we actually welcome help and contribution from anyone who has experience with assembly script and generally working with WASM. Okay, that concludes this slide, which brings us to the AMA. Telegram group QR code, followed by Discord, our Discord QR code, followed by our GitHub QR code, where you can read all our code bases. We welcome collaboration, and this is a daunting challenge, but a very exciting endeavor. And we genuinely welcome you to join us, and you can ask us any question.
There was a question, there was a mention in the chat from, I really cannot pronounce your name. He has a spaceship, I think. That he said he was trying to define topology as a conflict resolving data with BFT consensus. And then we had a question from Dudes asking if you can explain what topology is about. Briefly, and since you already went over everything of topology, like the how, and I wonder if you could tell us about what is the mission, what is the overall, what are we aiming with all of that that you just explained?
Yeah, great. So maybe to address the first question first, I didn't get the full question. I remember conflict resolving data and
conflict resolving data with BFT consensus. Is
so
that
the question?
topology? If that is topology, he was trying to explain what he knows about topology.
Right. Yeah, I think you're super close. There are things that we can be pedantic about, but we don't have to. I think that yes, we are using technologies that are dealing with conflicts, and specifically, they're dealing with conflicts in a way that makes conflict resolution automatic and very fast. And so, in that sense, I don't know if you already understand what conflict means. If you go to blockchain, usually a blockchain sees every transaction as conflicting with every other transaction. That is the default mentality of a default blockchain. And so how does a blockchain resolve conflicts? Well, it uses, you call it sequencing or you call it ordering. It's all the same thing. Is all these transactions are conflicting, so let's find a way to order them and to see which one should be included in the block and which one should not be included maybe later in future blocks. And that process is basically trying to resolve conflicts. And the way blockchain resolve conflicts is basically, on an abstract sense, all the validator nodes or all the nodes that are doing the hard work, doing the mining, or all the nodes that have stake in the network to participate in a voting process or competitive process to try to solve that conflict and to earn rewards by doing so. So that's blockchain. I don't think blockchain projects talk about conflict resolution, because conflict resolution really is a different mental model at the same thing. But we talk about conflict resolution because we use a technology called CRDT, which is a technology that we didn't invent, but it actually existed for more than a decade already. But it has a long history, and it didn't start out being a Web3 application because it was invented roughly 2007. There was no blockchain, strictly speaking, yet. And over the last decade, CRDT, this technology, has been used to create things like databases that work across the globe, and also collaborative applications like text editors and collaborative canvas and mocking tools and so on. But we believe that CRDT is a technology that is perfect for achieving our mission. And this brings us to the next question, which is, what is our mission, right? Because we talk about the how, but maybe we can talk about the what here, or the why here. So one way to say our mission is we believe in the vision of the Open Metaverse. And when we say Open Metaverse, we don't mean it as open world video game worlds that are connected and anyone can look like any avatars and so on. Yes, I think that's part of the picture, but we mean much more than that. We mean Open Metaverse. When we say Open Metaverse, we mean it is an open medium where anyone can create and deploy and access other people's creation as software and as content. And more importantly, these software and these programs, they need to support real-time multiplayer access. It doesn't have to be a game. So I'm saying multiplayer in a generic sense, not in the video game sense. These software should support many people, much more than 100 people, as in like a Fortnite game, much more than a Fortnite game session, accessing the program at the same time and in a way that's richly interactive and dynamic. And that is the general definition of the Open Metaverse. Another way to say this is the following. So if we look at the web that we use every day, and if we sort of go back in history to 1990s, that's when the web was invented, around 1991, 1992. The web was originally for transmitting information from one machine to another machine. So the machine that transmits information is the server, and the machine that asks for the information is the client. So that is the web in its original design. And we have HTTP. So any URL that you type on the browser URL text box starts with HTTP or HTTPS nowadays. It used to support many more protocols, and it still does. But nowadays we only use HTTP and HTTPS, right? And this protocol is meant for transmitting information across the internet between two machines, the server, which serves information, and the client who asks for information. But I think nowadays we agree that we don't go online just to ask for information, right? Like here on Discord stage, we are here not primarily to ask for information, but we're here to hang out, to interact in real time, and to be together, but in a digital space. So this was not what the web was originally designed for, but we are abusing the web architecture to do this. And Discord is built over the internet and uses web protocols and so on. The idea is that we want to enable real-time interactions being together on the internet, but in a way that's fully decentralized, meaning that we don't want to do this in a client-server way. Like when we hang out on Twitter or on Facebook or on Discord, what we're really doing here is we're hanging out on Discord server. And so there are servers that are run by and maintained and operated by companies, and they control what happens and what should not happen on a Discord in a general sense, like what the software looks like, what functionalities are enabled. Every upgrades, they dictate what upgrades include and what features go and what features stay. So they have total control over what runs on their server, and we're just hanging out on their server. And it works great, right? We're using Discord stage to hang out together right now. But we are imagining a alternate future where anyone can create multiplayer software like a Discord stage, but it is running peer-to-peer without server being the authority that is the choke point or the control point of the entire thing. And this multiplayer program that we hang out together is fully morphable and changeable and accessible by anyone. So that is the vision, and I don't think we are I don't think we are going to enable P2P Discord stage. I think that is not so interesting because Discord stage works really well now. I think what we're basically thinking is if we give CRO as this magical material that you can use to build permissionless P2P multiplayer, real-time multiplayer software of any kind, what can people build? And this thing doesn't rely on servers to operate. So it's like a new magical material that you can make applications with. And we're excited to see what people build with that. Metaverse things included, but Open Metaverse to us is a general purpose medium. It's not just about video games.
That is a beautiful explanation. Thank you, QC. And we have more questions in the chat. That's why I want to ask you to try to answer at least one or two. QB said, I don't follow what you said about the sync, but do you have some idea on how to sync more lightly? Maybe you already talked about this.
Synchronization, right?
Yes.
Yes. Okay. So we talk briefly about synchronization. Now, this can get very technical very quickly. So I'll try to be brief here, and we can talk about specific papers and specific techniques on Discord. But just to give you a brief idea, we talked about the naive way of synchronization, which is if I want to sync with you, you send me whatever you have, and I send you whatever I have. And once we have that, we can reconcile our differences. Right. So that is the naive way of synchronization. Now it may be not scalable in the sense that if you have 1 gigabyte of information about the CRO, and I also have 1 gigabyte of it, me synchronizing with you, requiring me sending over 1 gigabyte of data and you do the same with me, is just going to take up a lot of network bandwidth, and it's not a very good thing to do, right? And especially it gets funny if our 1 gigabyte of data each is only deferred by, let's say, 10 kilobytes, then sending all that data over the internet seems wasteful. If we can just realize what exactly is our differences and we just talk about our differences, right? That's much easier. So there are techniques to reconcile information that are much more efficient than sending the whole set of information. And specifically, in the mathematical sense, we're talking about reconciling sets. So a mathematical set is a unordered collection of information. So I have a set of things, you have a set of things, we want to reconcile our differences so that my set becomes the same as your set at the end of the process. There are algorithms that can figure out our differences of the set and only send or encode information in such a way that it's much more compressed, and we still reach a synchronized set at the end. And specifically, we are using we are going to build on top of a paper that's recently published, which is called RIBLT. It's a very long name, but it basically means that it is a practical design of RIBLT, which means rateless, invertible, Bloom lookup table. So it is a really mouthful thing. But the idea is that if you can just send me something that is much shorter than your entire set, and I can send you something that is also much shorter than my entire set, but that little thing that we exchange can already tell each other the differences, then it saves us a lot of time. And this RABLT paper proposes a very smart way to even make this little thing that we exchange even smaller than previous approaches, in a way that involves coding things and decoding things in a way that is sort of asymptotically constant over the set sizes, set difference, if that makes sense. So just to be precise on the very last part that I just said, if our differences is very large, then we might be exchanging things that are also very large to be able to describe our differences, which is very large. But the RABLT paper has a way to allow communicating our differences in a way that sort of over time, when you sort of look at larger set sizes, if you plot set sizes, set difference as x-axis and synchronization complexity on the y-axis, the trend is that it is a constant complexity. So it doesn't care about how much different we are. The thing that we do in order to synchronize stays roughly the same. And that almost sounds like a magical property. And it is indeed a very wonderful paper. And we're looking to implement that in our protocol.
Nice. There's only one more question. I know we're on top of the hour. Maybe we save this question for next week. You let me know. I will say the question and you tell me if it's quick to answer.
Okay. Yeah.
It's Fluent, which is another L2 that, like Topology, works on blended execution on LLRL bytecode execution. So he's asking if the concept of execution is the same.
I actually didn't. Okay, so I think at this point I can stop sharing.
I think you can.
Yeah, just to flash the slide a little bit. Okay, I'll stop sharing and I can now check the Discord message. Okay, this one. Yeah, Fluent. I think they're building a rollup, if I'm not mistaken. They are using blended execution. Right. Okay. Yeah, so I think on that front, we share the same idea in the sense that, if we take a step back, but all these blockchains or protocols and whatnot, they're supposed to give superpower to developers, right? To make new kinds of applications or to make existing applications, but much faster, much easier. That's on a very high level what all these platforms and protocols want to enable the developers to do. And when we think from this perspective, WASM or blended execution means that you can blend different execution environments or runtime together. You can adapt to what the developers want. It's all about the same idea, which is being flexible to developers and supporting the environments that are most pervasive right now in the tech world. And WASM specifically, it is very cross-platform. It is like an abstract CPU that runs almost everywhere on any machine, which sounded like impossible decades ago. But with the help of and hard working of many Web2 companies, we now have a WASM as almost an industry standard, which works across machines. And so from the perspective of protocol makers and platform makers, if we can give WASM to the developers, that basically means that their creation can run on any machine, almost any machine on Earth. And that's a wonderful thing for them.
All right.
Yeah. I think one thing to elaborate a little bit more is that Topology Protocol doesn't assume any particular virtual machine. It also doesn't assume a blended set of machines or machine. It assumes that there is a virtual machine or some virtual machine that can run code, but it defines protocol for programs to run multiplayer concurrently. but we're using VM to implement our node because sorry, we're using WASM is because WASM is very cross-platform and it's wonderful. But it doesn't mean the topology protocol is tied to WASM. I hope that makes sense. Wonderful. Did we cover all the questions? Now just going through the chat history.
Yeah, we covered all the questions. And if you want to prepare, in 2 weeks from now, we have another community call. You can bring more questions for this discussion, but in between, you can also join our Telegram and ask questions there. Connect with the community. We are now in the Korean Blockchain Week. Many of the team are there, so we are posting many pictures and showing you what can happen at these events. And if you are planning to go to DevCon, please consider traveling a little bit before. We're going to share dates and all of that in a few days, but you should already know that we are going to be there before and during DevCon, so meet us in person. And yes, I think this is it. Thank you, Giti. It was a great explanation. All the topics, I think they were covered with such detail. And thank you everyone that joined today for asking questions and being here. Share with your friends that might enjoy the conversation as well, because it's very valuable time.
Thank you, everyone. And also thank you, Patty, for covering the DEF CON plans and the newsletter initiative and many more initiatives that we will be doing in the future.
Happy to be here. And yes, okay, some people are typing, but I think this is it. And the recording will be ready this week on YouTube. Check our Twitter to stay posted.
Wonderful.
Nice.
So let's wrap up the call now. Thank you everyone for coming to the call. And if you're in Seoul, definitely hit us up and we can meet up during KBW. If not, then we'll see you on our Telegram chat or on Discord server or on our GitHub if you send pull requests, welcome, or in our next community call.
Yes. All right. See you then.
See you. Cheers, everyone.